Okay, welcome to Midterm to Review. Here we are dealing with game trees again, and the first question requires us to fill in the node values after we have applied our minimax algorithm onto this game tree here. So as usual, we need to know that the outward triangle is the maximizer node, while the downward pointing triangle, they are the minimizing node. Okay, so if you are highlighting the maximizer and minimizing layer, um, there it is. And now we can start filling in the values. So at the bottommost layer, it is a maximizing layer. So we can just choose the larger values um, between the pair of values that is provided. Yeah, and the second layer, a layer up would be a layer of minimizing node. So we'll just choose the lesser value. Like between 4 and 3, we have 3. Between 1 and 2, we'll choose 1. Between -3 and 5, we'll choose -3. And now the root node, which is a maximizing node, it will choose the largest between 3, 1, and -3. So 3 is the value chosen. For part 4b, we have alpha beta pruning, and we prune a node when alpha is larger than beta. Okay, and at instantiation, alpha will take the value of negative infinity, while beta will take the value of positive infinity. And we start the algorithm from the root node. And this value pair get passed down from the root node all the way to the leftmost child node. Okay, and this leftmost child node is a maximizing node. So alpha gets to update its value. 4 is larger than negative infinity, so alpha gets updated to 4. However, -2 is not larger than 4. So now we go back to the parent minimizing node. Beta decides that 4 is the lesser value between positive infinity and 4, so it gets updated to 4. And this value pair gets passed down to the right child node, which is again a maximizing node. And alpha decides that, yep, 0 is larger than negative infinity, and 3 is again larger than 0. And back to the parent minimizing node, beta decides that 3 is the last value between 3 and 4, so it gets updated to 3. And now back to the top root node, which is a maximizing node. Alpha decides that between negative infinity and 3 is a larger value, so it gets updated to 3. And the value pair of 3 and positive infinity get passed down to the left child of the middle subtree. Okay, which is again a maximizing node, so alpha compares the value. Like -4 is not larger than 3, and 1 is not larger than 3. So the value pair stays the same. And now back to the middle minimizing node. Beta decides that 3 is a lesser value between positive infinity and 3, so it gets updated to 3. And at this point, we see that alpha is equals to beta, which fulfills our pruning rule. So the right child gets pruned. Let me make this bolder. Yeah. Okay. And now we go back to the root node. So which is a maximizing node, like alpha compares that, oh, 3 is equals to 3. So the maximizing value that it can get is still 3, so it does nothing. The value pair of 3 and positive infinity gets passed down again to the left child of the rightmost subtree. Okay, which is again a maximizing node, so alpha compares 3 with -3 and -5, and none of them are larger than 3. So again, this value pair stays the same. And now back to the rightmost minimizing node. Okay, beta decides that 3 is the lesser value between 3 and positive infinity, so it gets updated to 3. Again, at this point, alpha equals to beta, which fulfills our pruning rule. So again, the right child will be pruned. And here's our alpha beta pruning for this game tree. Okay, for the last part of question 4, we are asked, so which move should we make? And notice that here we have the outcome from part A. As we can see here, like the largest possible outcome that we can get for the maximizer is 3. And this value comes from the left subtree. So the move that we should make is go to the left subtree. Yeah, and that's it for question 4.